Terraform 1.5 introduced a new feature called check blocks. These blocks allow you to perform checks during plan and apply without blocking either process. Let's dig into how check blocks work and why you might want to use them. What's up, everyone? I'm Ned Bellavance, nedinthecloud.com, and today's topic is the brand new check block. While not quite as exciting as the import block, which was also introduced in Terraform 1.5, the check block has the potential to solve some interesting problems, especially around drift detection. In today's video, I'll walk through the basics of the check block, we'll see how it could work in practice, and then we'll talk about some of the possible use cases for check blocks. Let's get started. Normally, I'd open with a long-winded examination of the purpose behind check blocks, but let's jump straight into the code, shall we? If you're looking for the example files to go along with what you're seeing here, those can always be found in my repository, Terraform Tuesdays. The link is down in the description. The folder we're going to be working in is 2023-0808 check block, and there's a subdirectory that is for the check example. And in here, let's take a look at the syntax of the check block itself. I have a check block here, and the syntax is pretty simple. The block keyword is check, and it takes one block label as its name. You can have multiple check blocks in your code, but you cannot yet use the meta arguments like count or for each to create multiple instances of a check block. In fact, the check block doesn't support any meta arguments at the moment. Inside the check block, the only thing that's required is one or more nested blocks called assert. Each assert block includes a condition with a value that resolves to true or false, and an error message which will be displayed when the condition tests false. Aside from the assert blocks, you can include a scoped data source. Why would you use a scoped data source instead of a regular data source? We'll cover that in a moment as well, but first, let's see how it works in practice. Now, before we dig into the rest of the code, I want to give a shout out to Alif Samadin for her excellent blog post on check blocks. I'll link it in the description below. She's got some great examples of check blocks in action, and I based my code on her examples. So thanks, Alif. In my example code, we are using the Azure VNet module to build out an Azure virtual network with a single subnet. Using the Azure Virtual Machine module, we are provisioning a virtual machine running Ubuntu and using the custom data argument to pass a script that installs a basic Nginx website. To allow traffic to the website, we are creating a network security group and a network security group rule that allows port 80 traffic from any source. Now, I've already deployed these resources in my environment, but if you'd like to follow along, check out the README in the relevant folder of the Terraform Tuesdays repository. In the checks.tf file, I have the checks I want to run. Let's take a deeper look at the syntax behind the first block. The block is named website working, which I think makes it pretty clear what we're checking. Inside the block is a nested data source using the HTTP data source to query a website URL. If a scoped data source fails to resolve, it doesn't block the normal operation of a Terraform plan or apply. You'll receive a warning in the output, but the plan or the apply will continue. Now, that's in contrast to a regular data source, which will block the plan or apply if it fails to resolve. Below our data source is an assert block. The condition is the status code of the web request equal to the status code defined in a local value. The local value is currently using 200, but we could switch that up for 500 or 401. If the condition fails, the error message is displayed stating that the actual status code doesn't match the expected status code. Now, that's the reason you may want to use a scoped data source in a check block. On the first run of our Terraform plan, when no infrastructure has been deployed, the website doesn't exist yet, so the data source will fail to resolve. Rather than having the check fail, it will simply warn us that the data source failed to resolve. Since the data source is defined inside of the check block and it's scoped that way, you cannot reference our HTTP data source outside of the check block. You can add a depends on or a provider meta argument to the data source block if you need to. Now for the URL, I'm referencing an Azure RM public IP address data source. That creates an implicit dependency between the HTTP data source and the public IP address data source. Now, why am I using a public IP address data source? Well, that's kind of an Azure thing. The public IP address type that we're using, if we look over in the main.tf file, is of type dynamic, which means it doesn't have an actual IP address until it's assigned to a network interface. If you try to directly reference the public IP address resource, you'll probably get a null value for the public IP address the first time you create the resources, and you'll get an error like I'm showing on the screen right now. By instead choosing to use the Azure RM public IP data source and creating a dependency on the module that's creating the server and the network interface, we've got a pretty good chance of getting an accurate value for the public IP address. I know that's kind of like an Azure thing, but it's an important thing to understand. Since the check block depends on the public IP address data source, we don't have to worry about the web request failing because there's no public IP address to query until after an apply. So let's run a Terraform plan with the code set to 200. I'll bring up the terminal down below and run Terraform plan. After a few moments, our plan completes successfully, although we do get a warning about one of the modules we're using. That's not related to the check block, so we can safely ignore it for now. If we scroll up through the output, Terraform shows that it is reading the scoped data sources during the plan. Since we don't see any warnings from the check blocks, we can safely assume that the checks passed. Now I'll change the code to 500 and rerun the Terraform plan. After a few moments, this time, we get a warning message stating that the assertion failed. The plan still completes successfully, but we have a clear indication that something is wrong with our website. Now, before we get into the rest of the defined check blocks, let's talk about some of the possible other use cases for check blocks. Check blocks can check pretty much anything, but we already have many ways to check things in Terraform. So why would you use a check block instead of the other options? Let's start with those other options and do a quick comparison. Variable validation blocks help you check the validity of variable values submitted at runtime. They are limited to checking the value of the input variable itself against some static conditions. Within that block, you cannot reference data sources, resources, or other input variables inside of the block. Next up, pre- and post-condition blocks are evaluated before or after a resource or a data source is created or updated. Unlike variable validation blocks, you can reference data sources, resources, and other variables in pre- and post-condition blocks. When a pre- or post-condition block fails, the plan or apply is blocked from moving forward. They also do not support the scoped data source block. Check blocks are a great way to check some arbitrary condition when you don't want to have it block an otherwise successful plan or apply run. Now, I believe the primary use case is to check on resources not directly managed by Terraform or on the status of objects that may change outside of Terraform's control, also known as drift detection and health assessment. A good example of a resource not managed by Terraform is the website we just tested. Although the startup script for the virtual machine installs Nginx, Terraform doesn't know anything about the website running on the virtual machine. We can use a check block to verify the website is up and running, and if it's not, we can alert on that condition. Now, it could be that Nginx isn't running, that port 80 somehow got blocked, or that the website itself is misconfigured. The fix might be doing something in Terraform, or it might be something else entirely. Another example is checking the status of a certificate. You can use the Azure RM App Service Certificate data source to query the status of a certificate. If the certificate is not in a valid state, you can alert on that condition and take action to fix it. Or if the certificate is going to expire soon and you need to renew it manually, you can alert on that condition and take action to renew it. Let's check out two other examples back in the code. In the checks.tf file, I have another check block that is meant to verify that only the allowed ports for a security group are open. Now, why would I need to do that? Shouldn't Terraform be managing the security group rules? Well, it is, but only kinda, as we'll see in a moment. Right now, the allowed ports include 80 and 443. The condition statement does some interesting things with Terraform syntax. I start by using the Azure RM Network Security Group data source to query the security group. Do I have the security group defined as a resource already? I do, but I want to query the security group as it exists in Azure, not as it exists in the Terraform code, and that's why I'm using the data source. In the data source is a list of security rules, and I'm parsing them with a for expression to capture the destination port range, but only if it's an ingress rule and only if the access is set to allow. Did you know that you can use filters on a for expression? Well, now you do. At the beginning of this expression, I'm using the setUnion function to combine the destination ports in the security rules with the allowed ports that I have defined in the local value. If the union of the two sets is equal to the allowed ports set, then that means there's no errant ports open. If the union of the two sets is not equal to the allowed ports, then there are destination ports defined in the security group rules that shouldn't be there, and we can print an error message that explains that the list of rules in that security group does not match what's in the allowed ports. So let's cause some trouble. Over in the main.tf, I've created the security group and security group rule as separate resources. And now I'm going to run an Azure CLI command that will add a new security rule allowing port 22 traffic from anywhere to the security group. Now that that rule has been added successfully, let's run a Terraform plan and see what happens when it completes. The plan has completed, and there's some interesting results. Sure enough, we get a warning from our check block that the assertion has failed. And if we scroll up a little bit, we see that the plan says that no changes are required. Why? Well, Terraform knows the security group exists, and that the security rule we defined for that security group also exists. But because we're not defining any rules inside the security group block, Terraform doesn't care about any other rules that are defined, just the ones it's managing. So if someone did open up port 22 to, say, fix an issue and then forgot to remove the rule, Terraform would never know about it, but our check block does. The last check block uses a data source to get the current power status of the virtual machine running the website. Let's shut down that virtual machine and see what happens. I'll grab the command here to deallocate the virtual machine and run the command down here. It'll take a few moments to deallocate, and then we'll run a Terraform plan to see what happens. Now that the virtual machine has been deallocated, I'll kick off a Terraform plan and we'll see what the results look like from that plan. Now that the plan has completed, let's scroll up a little bit, and interestingly, the plan says no changes. That's because Terraform doesn't care if the virtual machine is powered on or not, just that it exists as configured by our code. Now, since the public IP address type is dynamic and our virtual machine is now powered down, the website working check fails, but in a different way because there's no host in the URL that's passed. We also still haven't removed that SSH rule from our security group, so that check fails as well. And now we get a warning from our server on check block that the assertion failed because the power state is deallocated. Like I said, the Azure RM Linux virtual machine resource doesn't care about the VM's power state, only that it exists as defined. But our check cares, and now we get a warning. Of course, I would hope that you've got some other monitoring tools in place to check on some of these conditions, but check blocks could be a nice addition to your monitoring toolset and also combat infrastructure drift like our errant NSG rule. The real goal behind most of the check block stuff is to monitor health, like the certificate use case, or check for configuration drift that might not be detected otherwise. In both cases, you would need to have Terraform run a plan on a regular basis and look for warnings from the check blocks. Terraform Cloud has that functionality baked in for the business tier, but you could also do the same thing with GitHub Actions and a scheduled workflow. How do you detect if the checks have failed or passed? If you export an execution plan to a file and convert it to JSON, the results of the check blocks have their own top-level key. Inside is a list of maps with each check inside the map. You could parse that JSON file and look for check warnings and then take action based on the results. Perhaps that's a video for another day. The Terraform check block is a feature you can use to combat infrastructure drift and verify resources that aren't managed directly by Terraform. I think it's a great addition to the Terraform toolset, and I'm looking forward to seeing how people use it in the future. In fact, I would love to know how you plan to use check blocks. Let me know in the comments down below. Thanks as always for watching. If you're interested in watching another video, check out the one on the import block. Until next time, stay healthy, stay safe out there. Bye for now.